Hi guys, today we're going to be looking at IGCSE Additional Maths, October-November 2022, Paper 1-2. So we're going to start now. For the first question, we have a diagram that is in this format, and we are required to find the values of A, B, and C using the diagram. So for this graph, we can draw a principal axis in the middle of the graph. So this is what we call the principal axis, and A would be the amplitude of the graph. So this would be the amplitude, and we can see that it's 2. For B, we will take 2 pi divide by the period of the graph. So this is 1 cycle, and we know that this is 2 pi over 3. So the period of 1 cycle is 2 pi over 3. So we will get that B is equals to 3. And for C is basically the principal axis, which is -4. And we're done. Question 2. We will need to draw the graph of y equals to modulus 3x squared plus 13x minus 10, stating the coordinates of the points where the graph meets the axis. So first we will need to find our x and y intercept. For x-intercept, we can equate this equation to 0. Factorize it, we will get 3x minus 2 and x plus 5. So x would be 2 over 3 and -5. For y-intercept, we sub x equals to 0. Remember the modulus, and we would get modulus -10, which is a positive 10. So for a normal quadratic graph without the modulus, it would look something like this. So this would be -5, and this would be 2 over 3. But because of the modulus, everything that is below the x-axis, this part should be reflected in the x-axis, like this. So this should be how the graph looks like. Remember to erase the negative part of the graph. So this is how the graph should look like. And this would be a positive 10. Part B, we need to find the set of values of the constant k such that the equation k equals to modulus 3x squared plus 13x minus 10 has exactly 2 distinct roots. So this basically means that we have y equals to k and y equals to modulus 3x squared plus 13x minus 10, and these two graphs intersect at 2 distinct points. And y equals to k graph is basically just a horizontal line. So y equals to k can be here, 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 anywhere. Alright? And we need to find the set of values for k such that these 2 points have 2 distinct intersection points. Right? So let's say k is here. You can see that there are 2 intersection points, right? So that means if this is k, this is k, there will be 2 intersection points. If this is k, where it meets at the stationary point of the modulus graph, then it will have 3 intersection points. When it's here, it will have 4 intersection points. When it's at the x-axis, it would have 2 intersection points. Okay, so now we need to find the value of the stationary point. We need to find what this is, what this k value is, so that we know the range for our k value. So to find the stationary point, we can use the differentiation method. So dy dx can be written as 6x plus 13, and we equate this to 0. X would be negative 13 over 6. So our y value would be modulus 3 minus 13 over 6 squared plus 13 times 13 over 6 minus 10. So this would give us 289 over 12. So now we know that this point here is negative 13 over 6 and and 289 over 12. So this would be y equals to 289 over 12, right? So we need to make sure that the k value is larger than this value so that it has 2 intersection points with the modulus graph. So once this line is above this point, it would give us 2 intersection points. That means k, the set of values for k, would be larger than 289 over 12. And don't forget about another one. When k equals to 0, it would also have 2 intersection points with the modulus graph. So k is also equals to 0. Question 3. Write this expression in the form of k, p to the a, q to the b, r to the c. Okay, so we can write the numbers in one fraction, and p, q, r can be separated into their own term. So now the numbers is 9 over 2 cubed times p. So now we have to group the indices of p together. So we have 2 times half. Square root p is basically p to the power of half. Alright, so the 3 here would be minus 3. And for q, we have half minus 1, because it's divide q to the minus 1. Okay, and r would be minus 3 minus 1 over 5. So we would get 3 over 8 times p to the negative 2 times q to the 3 over 2 times r to the negative 16 over 5. For question 4, we need to solve the equation of 3 sine 2x plus pi over 4 equals to sec 3 cos 2x plus pi over 4. So first step, we would need to change the range of x. So we will need to change x into 2x plus pi over 4. And for 0, we will need to take 2 times 0 plus pi over 4. So we will get pi over 4. And for pi, we would need to take 2 pi plus pi over 4. So we would get 9 pi over 4. So this would be our new range of of 2x plus pi over 4. And now we can start solving the equation. We can move the sine and cos to the same side. So we would get sine 2x plus pi over 4 divided by cos 2x plus pi over 4. And for the right hand side, we can move 3 to the right hand side and we would get sec 3 over 3. And sine over cos, we should know that it's tangent. So we get tangent 2x plus pi over 4 equals to sec 3 over 3. And we can first find the base angle. The base angle would be pi over 6. And now we know that 2x plus pi over 4 can be written as pi over 6 or 7 pi over 6 because it's a positive value. So it can be here or here. And from this range, we know that pi over 6 should be rejected. And we should have another value, which is pi over 6 plus 2 pi, which is 13 pi over 6. And this would still be in this range. And therefore, we can find that x is equal to 7 pi over 6 minus pi over 4 divided by 2. So we will get 11 pi over 24. And 13 pi over 6 minus pi over 4 divided by 2, we would get 23 pi over 24. Question 5a. Find the vector with magnitude 200 in the direction of 7 minus 34. So, to find this, we need to use the unit vector. So, this would be the unit vector in the direction of 7 minus 34. And they want a vector with magnitude of 200. So what we do is, we take the unit vector times 200. So we take 200 times this, and we would get a vector with magnitude 200 in that direction. So this would be 56 and negative 192. part B, we have a triangle AOB such that OA is A and OB is B. We have the point C lying on the line AB such that AC to AB is 1 to 3. So we need to find the vector OC in terms of A and B. Alright, so for OC, we can go from O to A and A to C, right? Like this. So let's write it in this way. OC is OA plus AC. And we need to find what AC is. So OA is A. We don't have to care about it first. We can sub it in later. AC, see, we know that AC to AB. Okay, I won't write it like this. AC to AB would be 1 to 3, right? So AC equals to 1 over 3 AB, okay? So AC is 1 over 3 AB, and now we need to find what AB is. AB would be OB minus OA, right? Or we can just find it this way, which is AB, we can also write it as AO plus OB. So AB would be AO plus OB. Alright, I'll erase this to avoid confusion. So now we can start subbing in A's and B's. So OA is A plus 1 over 3 AO would be negative A because it's in the opposite direction of A, right? This is A, this would be A, and this would be negative A. So we have AO as negative A and OB as B. So what we will get will be 2 over 3A plus 1 over 3B. And this will be the simplest form. Part C. Given the vector equation P times 2, 1 plus Q times 2, 4 equals to 5 times minus P plus 1, P plus Q. So for the left hand side, we can write it as 2P plus 2Q and P plus 4Q. And for the right hand side, we can write it as minus 5P plus 5 and 5P plus 5Q. Okay, so now we just have to compare this part, this equation, and this equation. So we can write this out. 2P plus 2Q equals to minus 5P plus 5 and P plus 4Q equals to 5P plus 5Q. So this can be written as 7P plus 2Q equals to 5. This will be our first equation. And our second equation will be Q equals to minus 4P. So we can sub the second equation into the first one, and we would get 7P plus 2 times negative 4p equals to 5. Negative p would be 5, and p is equals to negative 5. And for q, we know that it's minus 4p, so it's minus 4 times minus 5, and this will give us 20. Question 6. A group of 15 people includes 3 brothers. A team of 6 people is to be chosen from this group, and the 3 brothers must not be separated. Find the number of possible teams that can be chosen. So the 3 brothers are either in the group together or not in the group at all. And first situation, they are in the group together. Second situation, they are not in the group at all. If they are in the group, we can now choose from 12 people. So since they are already in the group together, we have 3 more vacancies in the group left. So 12C3 would be the first situation. This would give us 220. In the second situation, they are not in a team at all. So same thing, we would have 12 people to choose from, and we would have 6 vacancies left because they are not in a team and the team needs 6 more people. So 12C6, and this would give us 924, and in total we would add them up to get 220 plus 924, and we would get 1144. Question 7. We have a diagram that shows a circle, center O, radius 10. Points A and B lie on the circumference of the circle, and the tangent at A and B meet at the point C. Angle AOB is theta radians. The length of the minor arc is 28 centimeter. So this whole thing will be 28. We need to find the value of theta. So we have the formula. R theta is equal to the arc length, right? So R would be 10 cm, theta would be theta. Arc length is given as 28. So now we know that theta is 2.8. Okay, for part B, we need to find the perimeter of the shaded region. So the perimeter, let's look back at the diagram. It would be AC plus BC plus 28, right? So AC plus BC plus 28. And how do we find AC and BC? We know that if AC and BC are the tangent to the circle, they should have equal length. So AC is equal to BC. So how do we find AC? So we can connect the center of circle to point C, and AC is a tangent to the circle, so this would be 90 degrees. And now we know that theta is 2.8, so this angle would be 1.4, right? So how do we find for AC? We can use SOHCAHTOA method. We already have this angle. AC would be the opposite, and AO would be our adjacent length. So tangent 1.4 is equal to AC over 10. So AC would be 10 times tangent 1.4. Okay, so the perimeter would be 2 times the 10, 2 times 10 tangent 1.4 plus 28. And this would give us 144 cm. For part C, we need to find the area of the shaded region. So the area of the shaded region is basically the area of this kite kind of shape minus the area of this sector. Alright? So to find the area of this kite shape, we just need to take the area of AOC times 2, right? So how do we find this area? We have the length of AC, which is 10 times tangent 1.4. So we can just take half times 10 times 10 tangent 1.4, right? So the area is 2 times half times 10 times 10 tangent 1.4. This would be the area of the kite minus the area of the sector of the circle. So what is the formula for area? It would be half times r square theta. So r is 10, theta is 2.8. So this would give us 440 cm squared. Question 8. We have a function of x such that fx equals to ln 2x plus 3 plus ln 4. We need to write down the least possible value of a. So from here we can see that they want us to find the domain of x. And how do we do that? We know that non-graph, they will have an asymptote. And how do we find the asymptote? We would take this part of the equation and equate it to 0. So we just take 2x plus 3 equals to 0. And x would be negative 3 over 2. And this would be the domain of the graph. And we know that the least value of a equals to negative 3 over 2. Part B. Using the value of a, write down the range of f. See, this is a very tricky question. We know that for long graph, I'll do a rough sketch. For long graph, it has a shape like this. So this would be the asymptote. X equals to negative 3 over 2, right? And this would be our fx graph. And you can see that it doesn't affect the range of the f function, because when a is negative 3 over 2, the graph is basically going through the whole thing, right? Unless they state that x is, let's say, negative 1. So if x is negative 1, it would be here, right? X is negative 1, and we would find for the y value. So now since x is just negative 3 over 2, which is the asymptote, we know that the range of f is basically all real values. We can write it like this. Part C. Using your value of a, find f inverse stating its range. So for f inverse, we switch x and y. So now we would have x equals to ln 2y plus 3 plus ln 4. And now we need to make y the subject. So we would have ln 2y plus 3 equals to x minus ln 4. 2y plus 3 equals to e to the power of x minus ln 4. 2y is equals to e to the x minus ln 4 minus 3, and y would be half times e to the x minus ln 4 minus 3 over 2. So now we change the y back to f inverse, and this would be the answer that they want. And don't forget about the range. The range of f inverse is basically the domain of f. So the domain of f is x more than a, and a is negative 3 over 2. So we have the range as f inverse is more than negative 3 over 2. Part D would be graph sketching. So we will need to sketch the graphs of y equals to fx and y equals to f inverse x, stating the exact intercepts of each graph with the coordinate axis. Label each of your graphs. So we would now sketch the y equals to fx graph first. So we know that we have an asymptote here. It would be x equals to negative 3 over 2. And let's make it a dotted line so you won't get confused by the actual graph and the asymptote. So starting from the asymptote, it goes further and further from it. Okay, I think this is quite okay. This would be our fx graph, and we know that fx and f inverse they should be reflection of each other in the line of y equals to x, right? So for our f inverse, the asymptote would now be y equals to negative 3 over 2. So this would be the asymptote for f inverse. So you can see that from x, now we get y equals to negative 3 over 2. And same thing, let's make this a dotted line so we just won't get confused. Okay, and our f inverse graph would need to be a reflection of our fx graph in the y equals x line. So it should be going from here. Oh, one more thing. They should meet in these 2 points because it's a reflection, right? So it goes like this. Okay, this is a bit ugly. Yep, this is okay. So this would be my F inverse graph. And now we need to label the intersection with the coordinate axis. So let's find for the x and y intercepts. For the x-intercept of fx graph, we can put ln 2x plus 3 plus ln 4 equals to 0, and ln 2x plus 3 would be equals to negative ln 4, and this is equals to ln 1 over 4. So 2x plus 3 is 1 over 4. X would be negative 11 over 8. And for the y-intercept, we can let x equals 0. So we have ln 2 times 0 plus 3 plus ln 4. And we would get ln 3 plus ln 4. And it's when we have an addition of 2 ln, we can put it into ln 3 times 4. And this would be ln 12. So this is negative 11 over 8, and this would be ln 12. And for f inverse, it's the other way around. So this would be negative 11 over 8, and this would be ln 12. And that's it. Question 9a. We need to prove this entire equation. So we just need to let all these fractions have the same denominator. So the first one, we can multiply it by 2x plus 1 and 4x minus 1. The second one, we can multiply it by 4x minus 1. And the third one, we can multiply it with 2x plus 1 squared. So now, the denominator would be 2x plus 1 squared times 4x minus 1. And now we need to expand the brackets. So we would have 8x squared minus 2x plus 4x minus 1 minus 4x plus 1 plus 4 times 4x squared plus 4x plus 1 over 2x plus 1 squared times 4x minus 1. And we will get 8x squared minus 2x plus 16x squared plus 16x plus 4. And for the denominator, we just copy it back. And finally, just simplify the numerator. So we will get 24x squared plus 14x plus 4 over 2x plus 1 squared times 4x minus 1. And that's it. It's exactly the same as what they want. For part B, we need to find the integration of this fraction. But from part A, we know that this fraction here is equals to all these fractions. So we can just sub all of this into this so that we can actually integrate them. Okay, so the integration of half to 1, and we sub all these fractions in, minus 1 over 2x plus 1 squared plus 4 over 4x minus 1. Okay. For 1 over 2x plus 1, the integration of it would be half times ln 2x plus 1. And for 1 over 2x plus 1 squared, we would have 2x plus 1 to the power of negative 1 over minus 1 times 2. And for 4 over 4x minus 1, we would have 4 ln 4x minus 1 over 4. So we would get half ln 2x plus 1 plus 1 over 2 times 2x plus 1 plus ln 4x minus 1. So we sub 1 and half into the equation, the expression. So we would get half ln 2 plus 1 plus 1 over 2 times 2 plus 1 plus ln 4 minus 1 minus half ln 1 plus 1 minus 1 over 2 times 1 plus 1 minus ln 2 minus 1. And we would get half ln 3 plus 1 over 6 plus ln 3 minus half ln 2 minus 1 over 4 minus ln 1. So for ln 3 and ln 3, we can write it as 3 over 2 ln 3. And for ln 2, we let it maintain as ln 2 first. And for the numbers, 1 over 6 minus 1 over 4, it's minus 1 over 12. And ln 1 is 0. So since they want it in the format of half ln p, let's make 3 over 2 ln 3 into the format of half ln something. So half ln 3 to the power of 3, because we can actually move the front number to the back and it becomes the power of this number, right? So we have half ln 3 to the power of 3 minus half ln 2 minus 1 over 12, and this would give us half ln 27 minus half ln 2 minus 1 over 12, and we can put these two ln together, so we get half ln 27 over 2 minus 1 over 12, and this would be our final answer. Question 10. The first three terms of an arithmetic progression are log x to the 5, and log x to the 9. So this is the first term, second term, and third term. Show that the sum to n terms of this arithmetic progression can be written as this. So we know that Sn is n over 2 times 2a plus n minus 1 d, and yes. So we need to find a and d. So a is log x as what is given here, and d would be log x to the 5 minus log x. Log x to the 5 can be written as 5 log x. So 5 log x minus log x would give us 4 log x. So now we can sub the values of a and d into that. So we would get so this can be written as n log x plus 2n times n minus 1 times log x. So we need to factorize the log x out. So n plus 2n times n minus 1, and the whole thing times log x, because we want it in that format. So n plus 2n squared minus 2n times log x, and it's equal to 2n squared minus n times log x, and factorize the n out, we get n times 2n minus 1 times log x. Part B. Find the value of n for which the sum to n terms is equal to 4950 log x. So we basically take the sum to n terms, which is this one, and equate it to 4950 log x. So n times 2n minus 1 log x is equals to 4950 log x, and we can cancel this 2. Cancel this 2. We would get 2n squared minus n equals to 4950. We move it to the left hand side, and now we can factorize this equation, and we would get n minus 50 and 2n plus 99, and we would get n equals to 50 and n equals to negative 99 over 2. But n should be a positive value, so we need to reject n equals to negative 99 over 2, and n equals to 50 would be the only answer. Part C. Given that this sum to n terms is also equal to negative 14850, find the exact value of x. So 4950 log x is equal to negative 14850. So we equate them together. So log x would be negative 3, and x would be 10 to the power of negative 3. Question 11. We have a particle P moving in a straight line such that t seconds after passing through a fixed point O, its displacement is given by s equals to 2t plus 1 to the 3 over 2 over t plus 1 minus 1. For part A, we need to find the velocity of p, and the answer should be in this form. So we know that the velocity of a particle is basically the differentiation of the displacement. So we have v equals to ds over dt, and we will need to differentiate this equation over here. So by using the quotient rule, we would have t plus 1 times 3 over 2 times 2t plus 1 to the 1 over 2 times 2 minus 2t plus 1 to the 3 over 2 times 1 over t plus 1 squared. And the differentiation of minus 1 would be 0, so I'm ignoring that. And now we can factorize 2t plus 1 to the 1 over 2 out. So we have 2t plus 1 to the 1 over 2. And the remaining part would be 3 times t plus 1 minus 2t plus 1 over t plus 1 squared. And now we would have 2t plus 1 to the 1 over 2 over t plus 1 squared times 3t plus 3 minus 2t minus 1. And the final answer would be 2t plus 1 to the 1 over 2 over t plus 1 squared times 2 plus t. Part B, show that P is never at instantaneous rest after passing through O. So if P is at rest, V should be equal to 0. So this whole expression should be equate to 0. And we would get t equals to negative half and t equals to negative 2. But time should always be positive values, so we need to reject the two t values. And therefore, v equals to 0 has no real positive solutions. Hence, P is never at instantaneous rest after passing through O. Question 12, which is also our last question here. We have to find the first three terms of the expansion of this expression here, and we need to find the values of A, B, and C. So basically we will expand these two brackets and then compare it with this expression over here. So now we can start. To the 5 and 1 minus b over x squared. Now you might ask, for this bracket over here, right, we have 6 terms in total. How do we know when to stop expanding? So if we expand fully, we would have 6 terms. And are they all needed to complete this question? The answer is no. Why do I say that? Alright. So for this expression over here, we can see that the expansion is 1 minus 2b over x plus b squared over x squared. And for this expression, we would have something x to the power 5 plus something x to the 4 plus something x to the 3 plus something x squared plus something x and plus a constant. Let's call it d here. So we can see that the question only wants the first 3 terms, which is something x to the 5, something x to the 4, and something x cubed. So if we take these 2 brackets and we multiply them together, there will be some terms that are not needed. And we can see that for this constant here, no matter which term we multiply it with, we would not get a term with x to the power of 5, 4, or 3. So clearly, this term is not needed. And for this term, if we times this, we would get something times 1 over x. If we times this, we would get just a constant. If we times this, we would just get something x, right? So we also won't get any terms with power of 5, 4, or 3. So clearly, this term is also not needed. For the x squared term, if we times this, we're going to get a constant. If we times this, we're going to get something x. If we times this, we're going to get something x squared. And again, we won't get any x with the power of 5, 4, or 3. So this term here is also not needed. And lastly, we can see that for x cubed, if we times the first term here, 1, we would get something x cubed. And we would see that it is actually needed. We need the x cubed term here. So this, we have to expand it until this term. So this answers the question just now. We just need to expand the first bracket up to the x cubed term. Well, of course, if you want to expand the whole thing, if you want to expand from x to the 5 to all the way to the constant term here, no problem. They won't give you wrong. It's just that we would waste a lot of time just doing unnecessary stuff here. So it would be best if you can figure out which term we need to expand until and just do what is needed. Okay, back to the question. So now we know that we just need to expand until the first 3 terms. So we have ax to the 5 plus 5c1 times ax to the 4 times 2 over 5 plus 5c2 times ax cubed times 2 over 5 squared. So we can stop here. Just write a plus dot dot dot. And now we expand this bracket. So we have 1 minus 2b over x plus b squared over x squared. For the first bracket, we'll get a to the 5 x to the 5 plus 2a to the 4 times x to the 4 plus 8 over 5 a cubed x cubed. And the second bracket remains the same. So now we can start multiplying all these terms together. So we would get a to the 5 x to the 5 minus 2a to the 4 b x to the 4 plus a to the 5 b squared x cubed plus 2a to the 4 x to the 4 minus 4a to the 4 b x cubed plus 8 over 5 a cubed x cubed plus dot dot dot. So you can see that I did not multiply these two terms together because these two terms would give me something x squared, which is not needed here. And I also did not multiply these two terms together because it would give me something x squared as well. And these two terms would give me something x, which is also not needed. So I just ignored all three of these terms. So now we group them together. We group all the coefficients of each term together. So we would get a to the 5 x to the 5 plus 2a to the 4 minus 2a to the 5b times x to the 4 plus a to the 5b squared minus 4a to the 4b plus 8 over 5 a cubed times x cubed. So now we get the expansion of these two brackets up to the term x cubed. So now we can compare the coefficients. So first we will compare these two. So a to the 5 equals to 32. And 32 can be written as 2 to the 5. So a would be 2. And now we would compare these two coefficients. So 2a to the 4 minus 2a to the 5b equals to minus 160. So we sub the value of a. So 2 times 2 to the 4 minus 2 times 2 to the 5b equals to minus 160. So minus 64b is equal to minus 192. So b would be 3. And lastly, we compare these two coefficients. So c is equal to a to the 5b squared minus 4a to the 4b plus 8 over 5 a cubed. So we sub the values of a and b. So we get 2 to the 5 times 3 squared minus 4 2 to the 4 times 3 plus 8 over 5 times 2 to the 3. So we would get 544 over 5.